Hello. In this video, we are going to look at chlorofluorocarbons, commonly called freons. These important gases are widely used as refrigerants, but also are implicated in destruction of the ozone layer. So here is a list of 12 of these compounds, along with their so-called freon code numbers. And we're going to see exactly how we get those code numbers from the formula. Our first example is free on 11. So we add the number 90 to it and we get the number 101. Now we interpret this three-digit number as the first number being the number of carbons, the second number being the number of hydrogen atoms, and the third number being the number of fluorine atoms. Using the common valence of carbon being 4, any unsatisfied valence we assume is going to be taken by a chlorine atom. So 101 means that we have one carbon, no hydrogens, one fluorine. So therefore, CFCl3 is free on 11. And here we see the three-dimensional structure of free on 11, CFCl3. And we have the optimized geometry on the left and the kind of stick diagram shown on the right. Here is Freon 12, so formula CF2Cl2. Here is Freon 13, so CF3Cl, with the optimized geometry on the left-hand side and the stick version of the structure shown on the right-hand side. Here is Freon 21. So notice here we have our first example that has a hydrogen atom. So we have CHFCl2 for Freon 21. Here is Freon 22. Remember, we add 90, so we would get 112, one carbon, one hydrogen, and two fluorines. And by the leftover valence, we know there has to be one chlorine atom for Freon 22. And the last of the monocarbon freons we're going to look at is Freon 31. So here we have two hydrogens, one carbon, and one fluorine atom. So left over, there's going to be one chlorine. Now, if we start with the formula, we write it in the version of a three-digit number, carbon, hydrogen, and fluorine. So we see for this particular freon, our three-digit number is going to be 211. Then we simply subtract 90 from it, and we get the freon code number 121. So the freon with the molecular formula C2HFCl4 would be known by the freon code number of 121. And here we see the molecular structure of Freon 121 with the optimized geometry shown on the left and the stick version of the structure shown on the right-hand side for C2HFCl4, Freon 121. For Freon 122, we have the molecular formula C2HF2Cl3, and we have the optimized geometry on the left and the stick version of the structure shown on the right. So here is Freon 131. Note that if we add 90, now we end up getting 221. So we have 2 carbons, 2 hydrogens, and 1 fluorine atom, and the structures are shown. And our final example is Freon 133. If you add 90, you get 223. So 2 carbons, 2 hydrogens, and 3 fluorine atoms. And therefore, we only have 1 chlorine in this molecule with the structures shown. I thank you very much for your kind attention. Stay healthy, stay safe, and as always, have a good one.